last video of the year. Let's do this. So what you need to know about negative exponents is that they move. So in this problem, x squared is positive, so it stays. Y to the negative 4, that's negative, so it moves underneath and becomes positive. X to the negative 3 moves up and becomes positive. And y to the negative 6 moves up and becomes positive. So if they're on the same side, like the x's, you add the exponents, that becomes x to the 5th. If they are on opposite sides of the fraction bar, then you subtract the exponents. So 6 minus 4 is equal to 2, and we know it goes on top of the fraction bar because the bigger number was on top. So that is our answer. No fraction left. Okay, for part B, we need to make sure that we know that the negative 2 has its own exponent and the a has its own exponent. And the exponent to the exponent rule, remember, a to the m raised to the n power, means you multiply the exponents together. So we're going to distribute this 3 into every exponent. So we get a to the 3rd, b to the negative 7. This is going to be negative 2 to the 3rd power, a to the 3rd power, b to the negative 6 power, times b. Okay, so let's take care of the number first. Negative 2 to the 3rd power is negative 2 times negative 2 times negative 2, which is a negative 8. Okay, and let's deal with the a's. We have a to the 3rd times a to the 3rd. That makes this a to the 6th. And we also have b to the negative 7 times b to the negative 6 times b. So negative 7 minus 6 plus 1 is b to the negative 12. But they said we can't have any negative exponents. So our answer comes out to negative 8, a to the 6. And since the exponent on b was negative, it drops underneath the fraction bar and becomes positive. For number 2, to simplify this, let's first off put this stuff in parentheses. And we're going to change this root to be a 1/6 power. So when that happens, you just multiply straight across, and this becomes x to the 2 over 18 power, which reduces to x to the 1/9 power. And that's our final answer for 2a. For 2b, again, we put this in parentheses and change the root to a 1/5. Make the 3 into a fraction by putting 1 underneath it. So we get 6 to the 1/10 times 6. 3 times 1 is 3. 1 times 5 is 5. So that's 6 to the 3/5. However, as it stands, we cannot add these exponents together because they don't have common denominators. So if we multiply top and bottom by 2, this becomes 6 to the 1/10 times 6 to the 6/10, and you just add the numerators to get 6 to the 7/10. Okay, for this next part over here, we're going to make this a fraction by putting 1 under it, and we are just going to multiply into both of them. So this becomes x to the 2/3. Down here. So if we rewrite this number in the denominator, that is the root that we're taking. So this is the square root of 16, and the numerator up here, that is our power. So we know the square root of 16 is 4, so this becomes 4 to the 3rd power, which is 64. For this one, even though the 2 is inside the root, we can still do that last. This is a third root. That means what number times itself 3 times is 27. So we've got 3 times 9 is 27, and 3 times 3 is 9. So we have a set of 3 3's. So therefore, this problem is going to be 3 to the second power, which is 9. Alright, next one. Root 18. Again, we're going to simplify this. We have 2 and 9. And this is a 3 and a 3. Since it's a square root, we're looking for pairs of numbers. So our answer is 3. And since 2 does not have a partner, it goes back underneath the square root sign. So our answer is 3 root 2. Okay. Next problems. Yeah, it's fine, I guess. Okay. So for these, for the numbers, blah, 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 select if the statements are true or false. All of these numbers are real numbers, and that is correct. That is true. Just because it's under a root doesn't mean it's not real. All the numbers are rational numbers. That one is false. Because, as number 4C states, they are all actually irrational numbers. If a number is underneath a root and it cannot be simplified, then we call it irrational. And these are not integers because integers are whole numbers. Okay. So we have a rule that if you have the square root of a times the square root of b, that's equal to the square root of a times b. You can multiply the numbers underneath the roots, but only underneath the roots, or you can also multiply them on the outside. So 5 times negative 2 makes that a negative 10. And 3 times 7 gives us root 21. That's our answer for A. Okay. So over here, negative 5 times 7, that's negative 35. 12 times 3 makes us the square root of 36. However, we can take the square root of 36. The square root of 36 is 6. And 35 times 6, and man, I cannot think right now. 175 is 210, I think. Use a calculator to double check me. Okay. So just like the rule that says we can multiply, we can actually divide them too. The square root of a divided by the square root of b is the square root of a divided by b. We can combine them into one root. So in the front, we have a 6 divided by 3. That's equal to 2. And we have the square root of 45 divided by 5. Well, 45 divided by 5 is 9. And the square root of 9 is 3. And 2 times 3 is 6. Okay. For the next parts, we can only combine things that are alike. So 8 plus 5 gives us 13. And root 3 plus root 3, since there's 2 of them, that means it's 2 root 3. Alright, next part. So we got a 7. We're going to distribute this negative first, though. So negative times 5 is negative 5. Negative times a negative is a positive 2 root 13. And we've got 7 minus 9 root 13. So 7 minus 5 gives you 2. Negative 9 root 13 plus 2 root 13 is negative 7 root 13. Okay, so solve for x. So again, we're going to put this in parentheses and turn that to a 1/4. So this becomes 18 to the 3/4 power. Same thing with this guy. This goes in parentheses. Fourth root becomes a 1/4. So this is times 18 to the 6/4 power, which is 18 to the 9/4 power. So since we're only looking for x, we're only looking for the top part, x is equal to 9. Okay. So for this one, again, we have to change the top part. So this is going to be 7 to the 5/12 power divided by 7 to the 1/3. Now, earlier in the video, I said you have to subtract them. However, there's a problem when it comes to subtracting them. You need common denominators. So to make this a 12, we're going to multiply top and bottom by 4. So this becomes 7 to the 5/12 divided by 7 to the 4/12. And when you subtract them, we get 7 to the 1/12. And since x is only looking for the bottom number, we get x is equal to 12. Select all the expressions. All of them. All of them. All of them. All of them. Okay. So, first off, what I might do is we're going to distribute this 2/3. So this is equal to 8 to the 2/3 times x to the 4/3. But 8 to the 2/3, the cube root of 8 is 2. So this is 2 to the 2nd power, which is 4. So they all need to be 4 times x to the 4/3 power. Okay, so for A, let's distribute this 2 in here first. So this is going to be equal to the cube root of 8 to the 2nd power, x to the 4th power. Sorry, dog's going crazy. So again, we can encompass this all in parentheses and change that root. So this is now 8 to the 2nd times x to the 4th, all to the 1/3. And we're going to distribute this 1/3 to make this 8 to the 2/3 times x to the 4/3. So therefore, A is equivalent. I'm going to need some more room. So for B, I guess we can do B over this way. B, we're going to have 8x to the 4th inside parentheses. And then we're going to have this as a 1/3. And as we distribute them, this becomes 8 to the 1/3 times x to the 4/3. And notice that 1/3 is not the same as 2/3. So not B. Okay. For C, let's change this one right here. So for part C, this is going to be 4x to the 3rd times, whoops, sorry, that's hard to read, 4x to the 1st times x to the 1/3 power. And again, you can only combine them if they have common denominators. So we're going to multiply this exponent, top and bottom, by 3 to make this x to the 3/3 times x to the 1/3. And when you add the exponents, you get 4 times x to the 4/3, which is the same as what we got in the other problem. So C is an answer. Okay. D is kind of an easier one. We have 4 times the cube root of x to the 4th power. Again, you just put parentheses around it and make this 4 times x to the 4th. And since parentheses is around the root, you only put the 1/3 on the parentheses, not the 4 in the front. And when you multiply them, you get 4 times x to the 4/3 power, which is the same. So D is another answer. And for part E, put parentheses around it. This is going to be 2x to the 4th power, all raised to the 1/3 power. And when you distribute them, this becomes 2 to the 1/3 times x to the 4/3, and that is incorrect. So those are only our answers, A, C, and D. Okay, next part. Okay, this will work if that thing will go away. Alright. Number 8. What? I must not have print screened it. Give it 1 second. Okay. Okay, so for number 8, again, let's put them in parentheses. So this is going to be 2x squared to the 1/4 power times 2x cubed raised to the 1/4 power, excuse me. And we distribute these in. So this becomes 2 to the 1/4 times x to the 1/4 times 2 to the 1/4 times x to the 3/4. Now, as you combine the 2's, 2 to the 1/4 times 2 to the 1/4, that becomes 2 to the 2/4. And as you combine the x's, x to the 1/4 and 3/4, that becomes x to the 4/4. And as you reduce the fraction, this is 2 to the 1/2 times x. Oh, I'm sorry. I made a mistake. I missed this 2 at the very beginning of the problem. I missed that guy. So this needed to be a 2/4 power on the x, which means this guy right here needed to be a 5. And that one would be answer B. My mistake. Okay, this should be the final answer over here, reduced, but they just didn't reduce the 2/4 for some reason. Alright. So 9. Select an equivalent expression. So again, the same kind of thing. So we have a 1/3 times a 1/3. Well, that means that it is going to be 3 times 3 is 9. So this is 1/9. And then to add the 1/4 and the 2/3 together, we need common denominators. So we're going to multiply by 3 top and bottom to 1/4. And we're going to multiply by 4 top and bottom to the 2/3. So this is 3/12 plus 8/12, which is 11/12. So it's 1/9 times x to the 11/12. C. Okay. Last part, number 10. We need to distribute. And let's change this guy. This is 8 to the 2/3 power. So 8 to the 2/3 times 8 to the 1/3 plus 8 to the 1/3 times 8 to the second. We can put that over 1 and make it a fraction. So 2/3 plus 1/3 makes that x to the 3/3. And then we're going to multiply this guy top and bottom by 3 because we need common denominators. So that's 1/3 plus 6/3, which means this is 8 to the 3/3 plus 8 to the 7/3. And we can turn this back into a root. This one over here would give us an answer of C. Okay. One last thing, then we're done with Unit 8. And after Unit 8, I'll do Unit 9, and probably take a little break. Okay. So this guy over here, 5 to the 3/8, that's all cool and dandy. But when we change this guy, this becomes 5 to the 2/4. So to make this an 8, we multiply top and bottom by 2. So this is now 5 to the 3/8 times 5 to the 4/8, which means you add the exponents to make this 5 to the 7/8. That's D. Okay. So for all these numbers, choose two numbers that when you multiply them, it is irrational, and when you add them, it is rational. So that means we're going to need some opposite things. So I'm thinking we need a √7 and 2 minus √7. We need one positive and one negative to add them and make them cancel out. Okay. So this first answer we're going to use √7 and 2 minus √7. Okay, so just to show you guys, if you multiply them out, √7 times 2, that's 2 √7. And √7 times negative √7, the roots undo each other, and you just have 7. So we multiplied them, and we got an irrational number. Okay, and if you were to add them, we have a √7 minus a √7. They would cancel and just be left with 2. So those are our two answers. So for B, we need to multiply them to be rational. So they need to multiply to get rid of a root. And when you add the same two numbers, it is irrational. So this one's kind of an easier one. You just have to pick two with the same root under them. So again, let's do √7 and 2 √7. So 7, 2 √7. Okay. If you add them, you get 3 √7, which is irrational. And when you multiply them, you get 2 times the square root of 49, which is 2 times 7, which is 14. So there you go. And then multiply them to make it irrational, so they should have different roots. And when you add the same two numbers, it is irrational. So this one's kind of an easy one. It's probably just going to be like a You can pick a lot of them. 2 and root 2 would be good. Okay. For 13, choose all the false statements. So for this one is false, because you're supposed to subtract them and not divide the exponents. This should be x to the 4th. Okay. This one is also false. When they're separated by parentheses, you're supposed to multiply them, so this should be y to the 8th. This one is incorrect. When the exponent's negative, you need to make it go across the fraction bar, and then it becomes positive. This one's correct. D is correct, because when you distribute that exponent, this is x to the 16th, y to the 12th, and x to the 4th. Okay, that's me breathing. I wasn't sure if you guys were hearing like the picking up the background noise from the TV. And then for E, when you are separated by parentheses, that is also false. This needs to be b to the negative 20th, which is 1 over b to the 20th. Okay? Simplify the expression and select all that are irrational. So 3 times 5, that is going to be, whoops. Since I'm running out of room, I'm going to do some work on this side. So 3 times 5 is 15. And 2 times 18, that's root 36. But the square root of 36 is 6, and 15 times 6 is equal to 90. So it's not A. Okay. For B, that's 7 times root 36. But you can take the square root of 36, it's 6. And 7 times 6 is 42. That is rational. C is actually irrational, because you can divide what's underneath the root. You can't divide the exponents. You can divide the bases. So 15 divided by 3, that's the square root of 5, and that is irrational. Okay. For D, if you break it up, this is going to be 4 times the cube root of 27 to the 2nd power. And the cube root of 27 is 3. Again, you can do the little factor tree if you want. And 3 to the 2nd power is 9, and 4 times 9 is equal to 36. So that is rational. And for the last one, since these are two different bases on the root, actually we can simplify them. So if we simplify them over here, the root 18, that's a 2 and a 9, that's a 3 and a 3, and there is the 5 in front of it. So this is going to be 5 times 3 in front of the root, because there's a pair of 3's. And since 2 is by itself, it gets left under here. So this whole expression is now 3 root 2 plus 15 root 2, which altogether makes 18 root 2. Alright, that does it for Unit 8. Okay, Unit 9. How long is the video so far? 30 minutes. Whew. Alright, so for this one, just combine like terms. 5x squared, 2x squared, that's 7x squared. 3x, there's no other x, so it's just plus 3x. Negative 7 minus 8 is negative 15. Distribute this, so this is a negative 2x squared. That's a positive 8 now. So 5x squared minus 2x squared, that's 3x squared. There's no other x, so this is going to be a plus 3x. And negative 7 plus 8 is a positive 1. sorry about that. Okay, so we are going to distribute. So 5 times 7, that's 35. X squared times x to the third, that's x to the fifth. Y times nothing is just y. We have a minus, 5 times 4 is 20. X to the second power times x is x to the third power. Y times y is y squared. And then 1 times anything is just itself, so 5x squared y. For this next one, again, we need to distribute. So 3 times 4, that's 12. C times c to the second is c to the third. 3 times 5 is going to be 15, and just put a c on it. And then this is going to be a negative c times 9c will be a negative 9c squared. And we can't combine any like terms, but if we put it in standard form, we got to make sure that the exponents, or the degrees, go in decreasing order. Okay. For e, this is called double distribution. 3x times 2x is a 6x squared. This 3x times 7 is negative 21x. 5 times 2x, that's a 10x. 5 times negative 7 is negative 35. And we can combine the negative 21 and the 10 to make this 6x squared minus 11x minus 35. Okay. We're going to call this triple distribution. First, we're going to distribute the 2x to all of these guys over here. So 2 times 3 makes that 6x to the third power. 2x times x, that's going to be a 2x squared. 2x times 4 is a negative 8x. Now we're going to move the negative 5 through each of them. Negative 5 times 3 is negative 15. Whoops, actually, I like putting them underneath here. So negative 15x squared. Negative 5 times x is negative 5x. Negative 4 times negative 5 is a positive 20. And when we combine like terms, we get 6x to the third power. 2 minus 15 is a negative 13x squared. Negative 8 minus 5 is negative 13x plus 20. Okay. Next page. Okay. So you got to be careful with the squared. You can't distribute it like we did in the other one because this is a plus sign and it is not a multiplication sign. This is really saying multiply 3x plus 11 by itself 2 times. Whoops. And then you double distribute. Distribute the 3x, distribute the 11. 3x times 3x is 9x squared. 3x times 11 is 33x. 11 times 3x is 33x. And 11 times 11 is 121. So we have 9x squared plus 66x plus 121. Okay, this is 2, 5y minus 1, 5y minus 1. So let's distribute. So 2 still in front, but now this is a 25y squared minus 5y minus 5y plus 1. 2 is still in front, Sorry about that. Thought my dog was going crazy again. So this is 25y squared. Negative 5 minus 5y is a negative 10y plus 1. And since there's a 2 in front, we multiply everything by 2 to make this 50y squared minus 20y plus 2. Okay. For this next one, we distribute the x squared to both of these guys. So x squared times x squared is x to the 4th. X squared times negative 3 is negative 3x squared. And then 3 times x squared is positive 3x squared. And 3 times negative 3 is negative 9. So this is x to the 4th. These two guys actually cancel each other. Minus 9. Okay. For this one, let's do the negative. Distribute it. So we have 4x squared plus 9x squared. That's 13x squared. Negative 5x minus 2x minus 11x, negative 18x. And 6 plus 3 is 9. Okay. So for this one, there's a couple steps here. We're going to do the back ones first, just because that's how I like to do it. So x times x, that's going to be x squared minus 2x. Distribute the bottoms. That's going to be a positive 6x minus 12. Okay. And then combine them all to get x squared plus 4x minus 12. Okay. So that's the back part. However, in the front, we still have 3x plus 1 that we haven't touched yet. And now it's a triple distribution game again. Okay. So this becomes a 3x to the 3rd power plus 12x to the 2nd power minus 36x. And distribute the 1 all the way through. 1 times x squared is x squared. 1 times 4x is positive 4x. And 1 times negative 12 is negative 12. Okay. So that's equal to 3x to the 3rd power plus 13x squared minus 32x minus 12. Okay. The next part is factoring. Now with factoring, we're basically doing what we just did backwards. So there's two things you need to look out for. First off, notice how many terms are there. There could be 2 terms, or there could be 3 terms. Okay, and if there's 2 terms, you need to look for 2 things. You're either going to A, do difference of 2 squares, I call that dots, or B, look for the GCF. Okay. So if you notice in A, 12 and 18, you can't take the square root of them. So we're going to move on to the second one, which is GCF. The biggest number that goes into 12 and 18 is 6. And then we're going to look at the exponents. Now these have ones that you don't see. You take out the smaller one, and it has to belong to every single term. So since they both have an x to the first, at least an x to the first, that comes out, and y comes out. Now we divide. So we have 12 divided by 6 is 2. Then x squared, we took an x out. There's an x still left. Y to the 3rd, we took a y out. So this is y squared. Minus minus. 18 divided by 6 is 3. There was an x, we took it out. There was a y, we took it out. That's done. Okay. The other thing that we have, if there are 3 terms, we just guess and check. Okay. The front 2 need to multiply to be the front number. So the only things that multiply to be x squared are x and x. And things that multiply to be 10 are 5 and 2. So it's called guess and check because we have to check our answer. 5 times x is 5x. X times 2 is 2x. And notice that 2x plus 5x is equal to 7x. That's the checking part. Okay, so that's our answer for B. So again, we're going to guess and check. The first 2 need to multiply to be x. Our back 2 need to multiply to be negative 15. So we have a 5 and a 3. Okay. So if we check, 5 times x is 5x, and x times 3 is 3x, notice how in the middle it's a positive 2x. So we can make a positive 2x if this is a negative 3x. 5x minus 3x is 2x. So since this needs to be a negative 3x, the 3 is negative, 5 is positive. And that is your answer. So again, first things need to multiply to be n squared. Last 2 need to multiply to be 36. I'm thinking 12 and 3. 12 times n is 12n. N times 3 is 3n. And since it needs to be a positive 9, that's a positive 12, negative 3. Fronts need to be a y. 21, I'm thinking 7 and 3. 7 times y is 7y. 3 times y is 3y. And since it needs to be a negative 4, the 7 needs to be negative. So negative 7, positive 3. Okay. Same thing, don't freak out. These guys have to multiply to be a in front. A squared. Multiply to 32, but add to 12. I'm thinking 4 and 8. But notice how there's a b squared on the end? Those both need b's. So 4b times a is 4ab. 8b times a is 8ab. And those two combine to make 12ab. So plus, plus. Okay. So this one's going to be a combination. Notice how in the front it's a 2, and those guys are all divisible by 2. So if we factor a 2 out, we're left with g to the second power minus 18g plus 45. So the 2 still goes in front, but now I need to guess and check. The front need to multiply to be g squared, so they're both g and g. The back need to multiply to be 45, so I'm thinking 15 and 3. And they both need to add to be a negative 18, so I think they're both negative. And you should check it. For h, notice there's 2 terms, and they're both square rootable. So this is called the difference of 2 squares. Square root of x squared is x. The square root of 36 is positive 6 and negative 6. Okay. Man, Unit 9 is long. Okay. Next part. Again, we are guess and checking. We need to multiply to be 5y squared, so 5y and y. You need to multiply to be 2. So here's the tricky part. You need to know where the 2 is supposed to go. 2 and 1. So if we check 2 times y is 2y, and 5y times 1 is 5y, but notice that 5y and 2y do not add to be 11y. They add to 7y, so something's wrong. That means we should switch the 1 and the 2 around. 1 times y is y. 5y times 2 is 10y. And y plus 10y makes 11y. So, therefore, our answer is going to be 5y plus 1, y plus 2. Okay, there's 2 of them. They're both square rootable. So this is difference of 2 squares. Square root of 9 is 3. Square root of x squared is x. Square root of 25 is 5. One's plus, one's minus. Okay. This one over here, we need 2 numbers or 2 terms that multiply to be x squared. So I'm thinking x and x. 49 would be a 7 and a 7. And they must combine to be a negative 14x, so negative 7 minus 7 is negative 14. You can condense this to be an x minus 7 squared, because the same thing is being multiplied to itself. This GCF first, notice how they all have a 5 that they can take out, and they actually all have an a that we can take out. So 5 divided by 5 is 1. A to the third, we took an a out. There's an a squared left. 30 divided by 5 is 6. A squared divided by a is a. 45 divided by 5 is 9. There's no a left over. Okay. And we can check some stuff out. A squared is a and a. Two things that multiply to be 9 are 3 and 3. And 3 plus 3 is 6. So there we go. GCF, factor the 2 out. We get x squared minus 9. And notice that they're both square rootable. So this is 2 times x plus 3 times x minus 3. For this next one, I'm going to cheat a little bit. You should multiply them all out. However, notice how this is the front term that we're looking for. So if we just multiply all the fronts, 2 times 4 times 3, that all comes out to 24. And if we multiply all the backs, 2 times 3 times 5, we end up with 30. Okay. So which one of these is the other factor? So we know that they have to multiply to be x squared, so x and x. And we know one of them has to be a 1. So negative 6 divided by 1 is negative 6. And let's check. 1 times x is x. Negative 6 times x is negative, is negative 6x. And negative 6 plus 1 is negative 5. So our other answer is x minus 6. Okay. So again with this guy, we have an x squared. They should factor into 2 binomials. We have x and x. One of them has to be a plus 1. So we have 10. Sorry, not a plus 1. It's actually a minus 1. So we have 10 divided by negative 1 is negative 10. Let's check it. That's negative x. That is negative 10x. And negative x minus 10x is negative 11x, as it's supposed to be right there. So x minus 10 is our other one. Okay. So factor the trinomial. So when we factor it, we know the front two need to multiply. 3x squared, that's a 3x and an x. And we know the back ones need to be 15. So let's do 5 and 3. 5 times x is 5x. 3x times 3, that is 9x. And if they're both negative, that means we will get negative 14x. So therefore, those are both negative. And that means our answer here is D. Okay. That's a plus 7, so again, we've got to factor it. So front two need to multiply to be 2x squared. So we have a 2x and an x. Back two need to multiply to be 7. So let's do 7 and 1. 7 times x is 7x. 2x times 1 is 2x. And that's not good because it needs to be 15x. So let's go all the way back and switch the 1 and the 7 around. 1 times x is x. 2x times 7 is 14x. And when you combine them together, you get 15x. So it's 2x plus 1, x plus 7. Our answer is A. Alright, I'm going to cut it for right now because I'm not feeling too bueno. I will fill up Unit 10 and 11 tomorrow, and then I'll try to do 12, 13, and 14 by Wednesday, so that way Thursday could be good to go. Alright, have a good one. Oh my god, 52 minutes. Woo!